Okay, so chapter 9 talks about regression wisdom. So before we start, we're going to talk about the important vocabulary. Extrapolation is predicting y values for x values that are far from the ones used to find the model. So these are really risky because we're not always sure that those predictions are there, so they're sometimes just useless. Outliers, we know what these are. They're points that stand away from others. So these have high residuals and high leverage. We don't want outliers, and if we do have them, usually we have to do some special stuff specifically for them. Leverage are data points whose x values are far from the mean of x. So these points can affect the model and change, the slope of the line that is best fit. And then influential point is a point that if omitted, it varies the data results and it can form a different model. And then a lurking variable is a variable that is not explicitly part of the model, but affects the way the variables in the model appear to be related. So we'll talk more about all these in just a second. And then why are residuals important? So here is just the regular scatter plot, and then the residual plot is next to it. So you want to see nothing in the residual scatter plot. If you were to see a bend or a curve or a group or something like that, that would require our special attention to help us understand exactly what the data means. And then all data must come from the same group. When more than one group is found in a regression, we can graph them as subsets. So over here on the bottom left, you can see these are different subsets. So they're talking about sugar and calories in cereals. And so here's all of them together, but then these different lines represent the different shelves that they have at the store because each shelf has a different amount. So you would need to group these as subsets. And then, so as an example, each of the scatter plots shows an unusual point for each. Tell whether the point has a high leverage point, would have a large residual, or is influential. So because this is really far out here, if we were to change it up or down, it would change the way that that line of best fit is pointing. So it is a high leverage point. And then since it does follow this line of best fit pretty closely right now, it doesn't have that large of a residual. And it's not very influential just because it does fall along that line of best fit. And then here again, another one. So this point is very far away, so it does have a high leverage. It also would have a large residual because this line is probably going this way right now. If we weren't to have the point, and then it is influential because when we add the point, the line would probably start to come down this way. So it does have all three of these. It's influential, large residual, and is influential. Okay, so now we'll go over lurking variables. So there's always a possibility that some third variable is driving both the variables you have observed. So here we have life expectancy versus the number of TVs a person has. So it's positively increasing, but it's also positively increasing for the numbers of doctors per person that there are over here. So which one is it? Are TVs making people have longer life expectancies? Are more doctors causing longer life expectancies? So in first world countries, people can afford more TVs, and they'll also have longer life expectancy because they have more doctors. So you can see there's lots of variables going in to how long someone's lifespan is. And you can't just break it down into one, but we're able to separate it and see not a cause and effect relationship, but how they do affect each other. Scatter plots or summary values. So scatter plots of statistics and summarized over groups tend to show less variability than we can see if we measured the same variables on individuals. So over here we have the height and weight. So they basically just took the averages of weight for each different height value on the left side, and you can see that that data is more closely centered around the line of best fit, whereas over here when they took each individual's weight and they didn't summarize it or find the mean for each height, it's a little bit more scattered, larger residuals, and things like that. So it definitely changes when we're talking about summary values versus individual values. And then So to just go over everything, we need to watch out for subsets. So those are extra groups within our data. And if you do find those, try and group them or show lines for each subset so that you are able to understand the data more clearly. Create a residual plot, scatter plot to check the straight enough condition. So you should see nothing when you're looking at this. It should be completely random. That shows that the data is evenly spread out. It's not grouped. There's no other subsets. There's no lurking variables there. Outlier conditions. So for large residuals and high leverage point, you can create another graph to see what their impact is. So what the line of best fit would be with them there, with them not there, and things like that. And then extrapolation. So predicting a point is silly and useless sometimes just because we're not sure how that data changes after we reach a certain point and things like that. A strong correlation still doesn't indicate a cause and effect relationship because there could be lurking variables. So basically just always be sure or always know that you can never be 100% positive of a cause and effect relationship because there is always something there that could be affecting the way the data came out and all of the results. And then watch out for summary and individual regression. So there's going to be different. Summary is going to be more condensed, closer to that line of best fit, whereas individual regressions are going to vary a little bit more and have larger residuals. And then that's it.